Today we're going to do chapter 3, rates of reactions. It's on page 8 of inorganic chemistry textbook. Okay, so rate of reaction, remember when I said anytime you hear the word rate, it means something is divided by time. So rate of reaction is basically how the reaction is moving over time. Now it means how fast the reaction is going. Now some reactions takes long and some reactions are very fast. For example, this example they're giving here, rusting of iron is a reaction where iron and oxygen becomes iron oxide, and this is a reaction that happens very, very slowly. But then you have other reactions where it happens very fast. For example, combustion. So rate of reaction is just basically how fast the reaction happens and how fast reactants turn into products. That's the main thing. It's all about the reactants turning into products because that is what the reaction is about. Now, because we're dealing with rate, it means something is divided by time. Now, when a reaction happens, it's basically the reactants turning into products. So as the reaction is happening, reactants is getting less, it's decreasing because obviously it's getting used up, and products is getting more, it's increasing because as the reaction is happening, you are making more product. So the rate of reaction or reaction rate is actually meaning the change in concentration of reactants or products per unit time. So since it's a rate, it means something must be divided by time, and that specifically is concentration divided by time. So rate is equals to the change in concentration over the change in time. And just remember, concentration is in units of moles per decimeter minus 3, and then since it's divided by time, which is second, the units for rate is mole per decimeter minus 3 per second, or second to the minus 1. So if you break it down, it's actually like this: change in concentration over change in time, and delta means change, which means final minus initial. So it's the final concentration minus the initial concentration divided by the final time minus the initial time. Okay, now it's very important to know that as the reaction is happening, reactants are turning into products. So as the reaction is happening, products are actually increasing because in the beginning of the reaction, you didn't have any product at all. And then the reactants start turning into products, so products increases. So if you work out the change in concentration, which is final minus initial concentration for reactants, for products, you will get a positive value because products increases. But for reactants, as the reaction is happening, it's actually decreasing because reactants gets less and less and less because it turns into products. So if you work out final concentration minus initial concentration for reactants, you will actually get a negative value. Now, the negative value does not mean the reaction rate is slow or the reaction is happening very slowly or it's going backwards. It just indicates that it is for reactants. So every time you see a negative value for the rate of reaction, do not think it means it's a slow reaction. It just means that that reaction is done in terms of reactants. Okay, but it doesn't matter whether you're doing it with products or reactants. Time, which is final minus initial, always has to be positive. Time is always positive no matter what. Okay. Right, so that's one way of working out rate of reaction, which is change in concentration over change in time, and you can do it with change in concentration of products, which will give you positive number, or change in concentration with reactants, which will give you a negative number. Then there is also other ways of doing it, which is in terms of moles. So you can say rate is equals to change in moles over change in time, but if you're doing it with moles, now the units will be moles per second. The next way you can do it is change in mass over change in time. And since you're dealing with mass, the units will now be grams per second. And then the next way you can do it is with volume. So it will be change in volume over change in time, which will be in centimeter cube per second. But volume is not always in centimeter cube. Sometimes it can be in decimeter cube also. And then there's other ways you can measure rate of reaction, which is change in pressure, change in color, pH, or conductivity of electricity, depending on what you're using. But the most common one is concentration. And it doesn't matter which one you use, whether it's moles, concentration, mass, or volume, the units will always be something per second. It's all, can you see, it's all second to the minus 1 because it's always divided by time.